Okay, so our next podcast that we are going to do is about the normal distribution. So, the first thing that we have to think about when we think about the normal distribution is that it's set up like a typical bell curve, okay? And so it looks like a bell. In the middle is going to be our mean, okay? So, we're going to label that mu. And then there are 3 standard deviations above our mean and 3 standard deviations below our mean. So for example, if our mean is, let's say, 30, okay, and let's say we're talking about the average age that someone finishes medical school. So let's say the average age is 30. Let's say the standard deviation is 1, okay? Now, I'm just making up that data, so don't take it to mean that that's for sure actually what it's like. Okay, so mean is 30. Let's say our standard deviation is 1. That puts our mean of 30 in the middle, and then there's always 3 standard deviations above our mean, so 31, 32, and 33. And then 3 standard deviations below our mean. Okay, and so that's 29, 28, and 27. Now remember that within 1 standard deviation of the mean is approximately 68% of your population. Within 2 standard deviations is approximately 95%. And then within your 3 standard deviations is approximately 99.7% of the data. So right now, as we're looking at this, we can say that probably we know that my data is not accurate because I'm willing to bet that the average age that someone graduates med school, I'm willing to bet that data is more spread out than from 27 to 33. So that's how our typical normal curve is set up. Now, what we need to look at next is the standardized normal curve. So the standardized normal curve looks like our typical bell curve, but our standardized normal curve has a mean of 0 and a standard deviation of 1. That way when you go up your 3 standard deviations, you're at 1, 2, and 3. And when you go down your 3 standard deviations, you're at -1, -2, and -3. Now, your standardized normal curve is really important because these boundary markers of your standard deviations, those are actually what we are going to call z-scores. And your z-scores are what you can use when you're looking at a normal curve that you don't know the mean or standard deviation. You can look at how they relate to the standardized normal curve with the z-scores of 1, 2, and 3, -1, -2, and -3. It's also really helpful the way that the standardized normal curve is set up because the standard deviations above the mean are positive and the standard deviations below the mean are negative. So it gives you a clear picture of where you are on the normal curve. Okay, so let's look at a couple different kinds of examples here. The first kind of example is one where they give you the mean and they give you the standard deviation. Okay, when that happens, you are just plugging and chugging away in your calculators. The first thing that I recommend you do is draw a picture. Even if they don't ask you to, even if you don't think it'll help you, it's always a good idea to kind of draw what you're thinking about. So I'm just going to go ahead and draw this over in the corner here. So we draw our bell curve. The mean is, let's see, the mean is 450. Standard deviation is 20, so that means we have 470, 490, and 510. And then going down, we have 430, 410, and 390. Again, this is not something that is necessarily required. Could you do it without it? Maybe, but it always gives you a good picture of what you're trying to look at. Okay, so then it says, find the probability of x is less than or equal to 475. So, first of all, when we're doing a normal curve, on our graphing calculator, we are always using normal CDF. Normal The normal distribution is a cumulative distribution function, so I'm not even really sure why normal PDF is an option. We're always going to use normal CDF. Whenever you have a function that they're asking about the probability of something less than something or greater than something, bound only on kind of one side here, rather than x being between two numbers, you're going to have to use, because it asks for the lower bound and the upper bound. Well, if we say x is less than or equal to 475, 475 is our upper bound, but for our lower bound, we don't really want to have one. We want to go towards infinity. So since our calculator requires us to put one, the best thing to do in that case is to put the biggest number and the smallest number that your calculator recognizes. So that would be, if you're going to have to use negative infinity for your lower bound, you'll go ahead and use negative 1 times 10 to the 99th. That's the smallest number your calculator recognizes. And if you're going to have to use your upper bound for a positive infinity, you're going to do positive 1 times 10 to the 99th. So in this situation, 475 is our upper bound because it's everything under 475. So our lower bound is negative 1e, or negative 1 times 10 to the 99th. And then we fill in our mean and our standard deviation. Mean is 450, standard deviation is 20. Be careful with this because sometimes they're going to give you the mean and the variance. If they do that, you have to remember that the variance is just the square of the standard deviation, so you would have to square root it first. Okay, so once you enter that, you just hit it into your calculator and you hit paste, and it will give you your probability. So we get that our probability of it being less than or equal to 475 is 0.894. Now, the other nice thing about the normal distribution is you don't have to worry about the difference between x is less than 475 and x is less than or equal to 475. Both of those are going to be the same probability, and you get to enter them the same way, unlike the way it is with binomial distribution. Okay, so then they also say in the second part of the problem, given that the probability of x is greater than a equals 0.27, find a. So this is a situation, in the last one, remember, we knew the boundary was 475. Okay, so we were looking for this whole area at 475 and less, and we were trying to find this area, which is the percentage probability. So we knew the boundary here, and we didn't know the percentage. In this next problem, we don't know the boundary. The boundary is A, and the percentage, or the area, is 0.27. So if I just were to draw a normal curve, the probability of it being greater than A is 0.27, so 27%. So that's somewhere, let's say, around here. Here's A, and here's 0.27. Okay, that area is 0.27. Now, the thing is, with your graphing calculator, it's when you're going to do a reverse problem like this, an inverse problem, where you're going backwards, it's always going to calculate the area to the left of the boundary. So if I put in 0.27 right now, instead of calculating what we want it to, this area to the right, it would actually calculate it as the 0.27 as if the area is to the left. So we need to actually do a complement here. So we're going to say, okay, if the probability of x being greater than a is 0.27, what's the probability of x being less than a? And so we're going to do 1 minus 0.27 to give us a 0.73 probability that it's over here to the left. Okay, and so if I was going to draw a picture, I might draw it like this. Area is 0.73, the boundary is A. So when I want to go backwards like this, where I'm trying to find a boundary and I know the area, I'm going to go back into my second distribution. Instead of choosing normal CDF, which is what we used last time, since we're going backwards, we're going to do inverse normal. Hit enter. It prompts us for the area, so we're going to put 0.73. The mean, we are going to put 450, and the standard deviation of 20. And that gives us that A must be 462 to 3 significant figures. Again, we did it that way because our graphing calculator is always going to assume that the area you enter when you do inverse normal is the area to the left. So if you're given the area to the right, you have to do the complement. Okay, so let's go ahead and look at another kind of problem. In this second kind of problem, they give us one of the key pieces of information. They tell us the mean is 21, but we're missing the other key piece of information, which is the standard deviation. So I can partially draw just a sketch of what the normal curve looks like. We know that this is 21, but we don't know what the standard deviation is. Now, it does tell us that 80% of the students have scores less than 23.7, so I can add that to my drawing. If this is 23.7, then the area to the left is 80% or 0.80. Okay, so let's go ahead and draw our standardized normal curve. Any time at all that you don't know a mean or don't know your standard deviation, you're going to have to use your standardized normal curve. So I'm just going to go ahead and draw it. 0, 1, 2, 3, -1, -2, -3. Okay, and it says, we said before, it says 80% of the students have scores less than 23.7. Well, we want to match that up with a standardized normal curve. And so we want to match that boundary of 25.7 or 23.7 with a z-score on the standard normal curve. So where is 80% less then? Where is that boundary? Well, we're not exactly sure, but it's somewhere around here, right? 80% is less than that boundary, whatever that boundary is. And we don't know what that is, but we want to find that out. We're going to call that boundary z. Okay, it's our z-score. So we're equating this 80% is less than z to this 80% is less than 23.7. We're almost imagining that we could that those proportions are exactly the same, and we just want to match them up. Okay, almost as if we're laying them on top of each other. So in order to do that, we have to think about it as a problem similar to this one right here. Okay, in this problem, we knew the boundary, right? It's 0.73. Or I'm sorry, we knew the area, 0.73, and we wanted to know the boundary, so we did inverse normal. Same thing with this. We know the mean and standard deviation. We know the area to the left is 0.80, and we want to find out what is the z-score. So we're going to do the inverse normal. Okay, so we go to second distribution, inverse normal, area is 0.80. Mean and standard deviation, since we're trying to find the z-score, the mean for this is 0, and the standard deviation is 1. And that's going to give us our z-score, and it tells us that z equals 0.8416, and so on. Okay? So we're basically matching those up, and we actually have a formula on our formula sheet. It says z equals x minus mu over sigma. That equation relates our two normal curves, the one in the situation of the problem and our standardized normal curve. And so our z-score we found was just 0.8416. Our x value, okay, I should have labeled this earlier, but our x value is this right here, 23.7, right? That's x, okay? So x is 23.7. Our mean, okay, it's our mean that goes with our x, so that's our mean of 21 right here. And then our standard deviation, that's what we're trying to find. Okay, so this x and this mu, that goes to our normal curve in the context of the problem. The z-score is the only thing that comes from here. Okay, so now all we have to do is solve that equation. Multiply both sides by sigma, and then divide by 0.8416. Okay, and so when we do that, we get our standard deviation to be 3.21 if we round to three significant figures. Okay, So once we've done that, the rest of the problem is not a big deal. It says a student is chosen at random. This student has the same probability of having a score less than 25.4 as having a score greater than B. Okay? Again, this problem is going to be a lot easier if we draw a picture. Okay? So here's a curve. Average is 21. And it asks us to find the probability that a student has a score less than 25.4. So I'm going to go ahead and mark 25.4 would be to the right of the mean. And we want to find this probability to the left over here. So we're going to go ahead and use our graphing calculator, going to second distribution, normal CDF. Our lower bound is negative 1 times 10 to the 99th. Our upper bound is 25.4. Our mean is 21, and our standard deviation we found in the previous part, which is 3.21. And that gives us that area to the left is 0.915. And so that's our answer to part BI. Now, why did they ask us to find that? Well, they're guiding us to the next part. It says right here that the student has the same probability of having a score less than 25.4. That's what we just found. So 0.915 is also the probability of them having a score greater than B. So let's just draw that curve for a second. We have a bell curve, we have B, and 91% is greater than B. So B must be really far over. And this area to the right is 0.915. Now, if we know the area and we're trying to find the boundary, we're going to use inverse normal. But again, we need the area to the left of the boundary, not the right. So in order to do that, I'm going to do 1 minus 0.915. I'm going to take the complement. And that gives me the area to the left is 0.085. Now I can go into my inverse normal, put my area as 0.085, my mean as 21, and my standard deviation as 3.21. And that gives us that B must be 16.6. Now don't move on before you see if that makes sense. That number should be less than 21, right? It should be to the left of it, and it is, so we're in good shape. Okay, the last kind of problem that you might see is a problem where they don't give you any piece of information that's key. They don't give you the mean and they don't give you the standard deviation. When that happens, they're going to have to give you at least 2 other pieces of information that are going to let us solve this problem. So the first thing I'm going to do is I'm going to write out the information that I know. It tells me that we're talking about the heights of flowers. It tells us that 20%, so that's 0.20, have a height of less than 3. So that's x is less than 3. And it tells us that 10% have a height greater than 8. Okay? So I'm just writing that information out. Just writing that out is going to get you method points. Okay? So make sure you write it out. Now, I am going to cross this out because before we can move on with this problem, we need to change it to a less than. Okay? So, because we're going to do an inverse normal eventually. So, probability of x is greater than 8 is 0.10. That means that the probability of x being less than 8 must be 0.9. Now, I'm going to go ahead and just draw one of each of these curves. Okay? The probability of it being less than 3, so to the left of 3, is 0.2. The probability of it being less than 8, so that's a lot of it, is 0.9. And I'm also going to go ahead and draw 2 standardized normal curves. I didn't do that very well. Let me try that one more time. Oh, that's okay. You guys have good imaginations. Okay, so standardized normal curve. We have some boundary z where the area to the left of it is 0.2. And you have another boundary z where the area to the left of it is 0.9. Okay, notice that these 2 standardized normal curves correspond to our other normal curves. Now, I am going to go ahead and set up 2 equations with our equations that relate z to x. In one of our equations, x is 3, and the other, x is 8. So I'm going to go ahead and write that out. Now we don't know mu, we don't know sigma, but we can find z. And so the way that we're going to find z is by using this picture to do our standardized normal curve with an inverse normal. Okay, so I go to second distribution, inverse normal. My area is going to be 0.2, mean is 0, standard deviation is 1. That's going to give me my z-score for when the x is 3. And that gives me negative 0.8416. And now I'm going to do the exact same thing, but this time the area to the left of z is 0.9. Mean is still 1, standard deviation, mean is still 0, standard deviation is still 1. And so z is 1.28155. Now, from here, this is just a system of equation, and I know that a lot of you are good at substitution with your systems of equations. That's totally fine. You guys can definitely do it that way. Since you guys are not as good at with elimination, I'm going to solve it that way so you guys get the extra practice. So the first thing I'm going to do is I'm going to multiply that sigma over to the other side. Okay, and now since they both have mu, and this is always going to be the case, I can take one of them and multiply it by negative 1. So now I get positive 0.8416, negative 3, positive mu. What that did for me is that lets me go ahead and add straight down and cancel these mu's. So 8 minus 3 is 5, and now I just add 1.28 with the 0.84. And so I get 2.123 sigma. And from there I just divide by that 2.123 on both sides, and I get sigma equals 2.35. Once I know what my sigma is, all I need to do is plug back into one of my two equations and solve for the mean. So I take that negative 0.8416 times 2.35. I subtract 3, and I divide by negative 1. And I get my mean to be 4.98. Before I move on from this problem, I should go back up and check my answer, make sure it makes sense. So we had said that 20% was less than 3, and 10% was more than 8. And so if that's the case, our mean should be between 3 and 8. And we did get that, so that's a good sign. And so we can go ahead and move on. That is hopefully a good review for you on the 3 kinds of problems you'll see with normal distribution. One where they'll give you the mean and the standard deviation. They'll ask you to go forwards and backwards with the area and the boundaries. The second way where they give you either mean or standard deviation, expecting you to find one or the other using z-scores. Or the third kind, which is where they don't give you the mean or the standard deviation, they expect you to use z-scores to find both.